Alright, so this time we're solving problem 35 from chapter 6, and the problem says, 3 identical 8.5 kilogram masses are hung from 3 identical strings. Each spring has the force constant of 7.8 kilonewtons per meter and was 12 centimeters long before any masses were attached to it. Part A, draw a free body diagram for each mass. And part B, how long is each spring when hanged as shown? And the hint is to work from the bottom up. So what we've got is we've got some kind of a, we'll say it's ceiling. We're going to have a spring attached to a box, attached to another spring, attached to a box, attached to a third spring, attached to a box. And I'm not great at drawing, but ideally the boxes and the springs should be the same size. So for part A, it wants a free body diagram for each one. So box A, B, and C. So for box A, you're going to have the tension from spring A, or the force from spring A, it's not a tension. Force from spring A, you're going to have the force from the mass times the gravity. You're also going to have the force from spring B, and this is for box A. For box B, you're going to have the force from spring B, its weight, and the force from spring C. And this is for box B. And then the last one is going to be box C. It's going to have the force from spring C, and then it doesn't have a spring down here, so it's just going to have its mass times the acceleration of gravity, or its weight. And so that is how you do part A, the free body diagrams for everything. So part B wants to know, because the weight attached to the spring is going to extend the spring, it wants to know how much each spring, the length of each spring. So we know, and kind of to make it easy, we're going to start at the bottom and work up. So the force, the net forces acting on the spring going to be equal to the mass times the acceleration. That's going to go to 0. And so you're going to have the force of the spring minus the mass times the gravity. And so then we also need the equation for the force from a spring. And so the force from a spring is equal to the spring constant times the distance that it's either compressed or extended. So we can substitute that in for that force. So we get that the spring constant times the distance is going to be equal to the mass times gravity. And then we're just solving for the x. So you divide k onto the other side, the spring constant. And then when you plug your numbers in, we know that all of the blocks have an identical mass. So the mass is equal to 8.5 kilograms. And we know that K is going to be equal to 7.8 kilonewtons per meter. And that's important because we're gonna have to convert it from kilonewtons back into newtons. So you're gonna have 8.5 times 9.8 divided by 7.8 times. So we know that 1 kilonewton is gonna be equal to 1,000 newtons. So that's gonna convert it back into newtons, because this portion is just in newtons, so we want all the units to all be the same so that they'll cancel. And so when you do that math, you get 0.011 meters. But the length of the springs was given to us in centimeters. They're 12 centimeters long. So we need to convert this into centimeters as well. So we just move the decimal place 2 points. So that's 1.1 centimeter. And that's how much it's stretched from the weight, but we also need, but it's asking for the total length of the spring. So we're gonna have to add that to the original length plus 12. So spring C has a distance of 13.1 centimeters. And that's the distance for spring C. So then we do the same thing for the other two, except for these other two, we have to include the force of the spring that's pulling down. So that equation, the equation for those is going to be equal to, is going to look something more like this. So the force of spring B minus the force of spring C plus mass times the gravity is going to be equal to 0. So we know that this is going to be the spring constant for spring B times its x minus spring constant for C times x for C, the distance for spring C, plus, well, I think these are minus as well because they're negative forces. So minus mass times gravity equals 0. Then when we isolate it for distance for spring B, you get K times the distance of spring C divided by K minus mass times gravity, or plus mass times gravity over K. So those K's will cancel out. And then plug in your numbers. So we know that the distance that spring C goes, distance of spring C is going to be 13.1 plus 8.5 times 9.8 divided by 8.7. And we once again have to do that conversion, 1,000 divided by 1, so that it's not in kilonewtons. And you come to, like when you do the math, you get that the spring was stretched 0.022 meters or 2.2 centimeters beyond rest. So the total distance is going to be 14.2 centimeters for spring B. So So we're then gonna do the exact same thing as we did before for spring A. But it's gonna resemble what we did for spring B. So we're gonna have spring constant for A times the distance of A minus the spring constant for B times the distance for B, this should be an A, minus the mass times the gravity. And that's going to be equal to 0 because the mass times the acceleration, there's no acceleration, so that goes to 0. Then you just isolate for the distance of A. It's going to be KB XB divided by KA plus mg times k of A. And then when we plug all our variables in, these k's are still the same because the springs are identical, so they're going to have the same constants. Those will cancel out. Our distance for spring B is what we found in the last problem, 0.014. You need to do that. This should have been 0.0131 because it needed to be in meters because this unit is in meters as well as is gravity. I forgot to explain that. That wasn't a problem in the for finding the first one because there was no other distance that we were using. So that plus 8.5 times 9.8 divided by 7.8 times 1,000 over 1. That'll give us the distance that spring A has stretched. When you do the math, you get that that is equal to 0.033 meters or 3.3 centimeters. So we then add that to the initial length of the spring of 12 centimeters, and we get that the length of spring A is going to be equal to 15.3 centimeters. So that's your answer. That's the spring length of spring A.